Welcome to the Math Record. Today I will introduce integration by substitution. So the basic idea of this method, as the name implies, is that you're going to substitute some variable in your integral with something else, so then it becomes easier to take the integral of. So let's understand this with some examples. Let's say you want to take the integral of x to the power 3 plus 4 to the power 3 of 3x squared in respect to x. Well, what we kind of notice is that when you take the derivative of this, you get 3x squared and derivative 4 0, and this is right here. And that's when you could use your u substitution. So you just need to have the I for it, and you'll get it once you do enough of these. So plus 4. And then we're going to take the derivative on both sides. So dx. So du over dx. The derivative of x cubed is 3x squared. The derivative of 4 is 0. So then what I'm going to do is I'm going to move dx to the other side. So then du equals 3x squared times dx. And then in all my examples later on, just know that I'm just going to write it in this form. I'm going to skip this step because it's basically just this moving over. But basically, when we take the derivative, I'm just going to leave behind a du. And then I'm going to take the derivative of the equation, and then I'm going to leave behind a dx. So basically, what do we notice about this? Well, we see this one right here. And this one is right here. So we could just substitute those in. So the integral, our x cubed plus 4 is our u, so that's u to the power of 3, and 3x squared dx is du. Well, that seems pretty simple. That's just a power rule. So the integral of that is u to the power 4. The derivative of u to the power 4 is 4u to 3. We want u to the power 3, not 4u3, so we use a 1/4 scalar. And as usual, since there's no numbers, we're going to add a c. But remember, we substituted in a u. Our original variables are x, so we got to substitute it back in. Our u was x cubed plus 4 to the power 4 plus c. So this is our integral. Okay, let's try another example. Let's say we want to take the integral of e to the power of 3x divided by 2e to the power of 3x plus 1. Let's say dx in respect to x. So usually when we're dealing with rationals, so something divided by something else, I like to substitute the bottom. So 2e to the power 3x plus 1. So then we take the derivative of this, du, and then 2. The derivative of e to the power 3x is e to the power 3x. And then there's an equation inside it, 3x, because it's usually e to the x. So 3x is inside e to the power x. So that means we chain it. So the derivative of 3x is 3 plus a 1. And then we're going to leave behind it, and the derivative of 1 is 0. And after that, we leave behind a dx. Okay, so from here, this kind of gets, let's multiply the 2 and the 3 out, so that's 6, 3x dx. Okay, so that doesn't seem like it matches anything here, but we're going to do integral of 1 over 2e to the 3x plus 1, and we're going to move this over here. It's just the same thing, it's still multiplied instead of being in the numerator, because they're basically the same thing. Being in the numerator and multiplying is exactly the same. So we recognize this is this. So that's just a 6 of du, so we multiply 6 to the other side. Okay, now we can substitute everything in, because we know what this is, that's u. So that means it's the integral of 1 over u e to the power 3x dx, that's 1/6 du. So this is a scalar, so we can move it outside. So 1/6 integral of 1 over u du. So as we said before, for these, it's going to be natural log of the absolute value of u. And remember a scalar, 1/6. There's no numbers, so add a c. So substitute our u back in. So 1/6 natural log absolute value of 2e to the power 3x plus 1, close absolute value, plus c. Okay, now let's do one more example that's a little bit more complicated. let's say we want to take the integral of x to the power of 5 of the square root of x squared minus 3 dx. Okay, so as usual, I usually don't like to work with radicals. I actually just like to work with exponents. So x to the power 5, x to the power 3 minus 3 to the power 1/2. Radicals, a square root is just the power 1/2. Okay, so if we take the derivative of this is 5x fourth. That doesn't match anything with this, so we're not going to do that. So we're going to use probably this equation. So let's say u is equal to x cubed minus 3. Take the derivative of this. The derivative of x cubed is 3x squared. The derivative of negative 3 is 0. And we leave behind a dx. Well, we don't have a 3x cubed here, but let's just move a 1/3 to the other side. So this becomes 1/3 du is equal to x squared times dx. And there is an x squared in here, but it's just separated. So let's rewrite this integral as x cubed minus 3 1/2. So I'm going to write that first. We're going to split this up as x cubed times an x squared, and then we still have our dx. So all I did was reverse the position of these two, and I split this to x cubed and x squared. Okay, so how do we get our x cubed? Well, I see x cubed here, so we're going to rewrite this as u plus 3 equals x cubed. And now we have everything. So the integral u cubed minus 3, that is u, so that's u to the power of 1/2 times x cubed, which we said was u plus 3. X squared times dx is 1/3 du. So overall, we have 1/3 going outside because that's a scalar and integral. Let's distribute this out to both of them. So that's u to the power of 1/2 plus 1 is 3/2. And 3 u 1/2 du. Okay, now we can just use the power rule on both of them. So the integral of this is add 1, so 3/2 plus 1 is 5/2. Let's move this a little bit higher. So the derivative of this would be 5/2 u to the power 3/2. So we need to scale this up by 2/5. Okay, plus the integral of this, we add 1 to the exponent, so that's u 3/2. Okay, so the derivative of this is 3/2 u to the power 1/2. We want just a 3, so we're going to have to multiply this by a 2. Okay, so we have everything. Now we remember we have a scalar 1/3. So big parentheses, we have our 1/3. There's no numbers here, so we add a c. So that means this is, so then let's substitute our u back in. So that's 1/3, 2/5. Our u is x cubed minus 3, 5/2, power of 5/2, plus 2, x cubed minus 3, power of 3/2, closure parentheses, plus c. And you can simplify this even further by multiplying 1/3 to both of these, but that's basically it. This is going to be our integral. Well, that's basically covering our u substitution. And we only, in this case, only have been using one u substitution, but you can actually use more if you want. So let's say we have the integral of sine of the sine to the power of 5 of x squared plus x, and let's say we have cosine of x squared plus x, and we're multiplying by 2x plus 1 dx. So this is a simple example on how to do this. So let's say we substitute, if we do the derivative of sine, it becomes cosine. But first we have our x's, so let's substitute that one first. So let's say u is equal to x squared plus x. So du, I'm just going to write this on the side. Du is equal to the derivative of 2x squared is 2x. The derivative of x is 1. Multiply that to dx. We leave behind dx. Well, that's there. And we have, let's actually just write that first. So sine power 5, that's a u. And then cosine of u. And then this simplifies to du. So everything's in terms of u. Okay, now let's use another substitution. Let's say w is equal to sine of u. So then when we take the derivative of w, we have the derivative of sine, which is cosine of u, and that leaves behind a du. Well, we see this is right here. So that means the integral. This is just sine of u is w, so that's w to a power of 5. And then we leave behind a dw. Well, this is just a simple power rule. So that's w to the power of 6. The derivative is 6w to the power of 5. So we need to scale this down by 1/6 and add a c because there's no numbers here. Okay, so substitute your w back in. So that's 1/6. And then that's sine to the power of 6. So sine 6u plus c. U, we substitute it back in with our x squared, so we get our original variable. So 1/6 sine of 6 x squared plus x plus c. And this is the integral of this equation. And that's basically it. You could use u substitution as much as you like, but don't get too overboard with it because sometimes you cannot just solve an integral using substitution. And this is why we have several videos in this series where we're going to cover how to do some how to do some integration. Well, thanks for watching, and in the next video, I'll cover integration by parts and something called the tabular method.